Number 70. Outline the steps needed to determine the limiting reactant when 30.0 grams of propane, which is C3H8, is burned with 75.0 grams of oxygen, and then we have to determine the limiting reactant, right? So first off, let's outline the steps. I'm going to try to write them down, but I will definitely talk them through with you. But the first thing is that if we need to find a limiting reactant or a limiting reagent, I might have said that in the beginning, but it's the same thing. The first thing we need is we need a balanced equation. Can't do anything without a balanced equation. So the good thing is that we've done tons of work learning how to get an equation and learning how to balance it. So this will kind of be a review, okay? So if you want, pause the video and try to find out what the balanced equation is between this propane and the oxygen. Now I'll give you a hint, guys. It is a combustion reaction, right? So give it a shot. But I'm just gonna go and work with this, quite quickly. So we have C3H8, and it's being burned with. Burned is the catchword to know that it's combustion. So it's this plus O2, and whenever we have combustion, you're always going to produce two products, which is carbon dioxide and water. Now all I have to do is just balance this. So there's 3 carbons on the left-hand side, so I'll just put a 3 over here. There are 8 hydrogens on the left-hand side. There's 2, so if I put a 4, I could say 4 times 2 is 8. And now let's see. I have a total amount of oxygen here. I have 6 oxygens plus 4 oxygens, so that's a total of 10. So thank goodness we do not need a fraction. All I have to do is put a 5 here, and we are good to go. Next thing that I would suggest is to write out what you got. Write down what is given. Pretty easy enough, right? So they told us that we have, 30.0 grams of the propane and 75.0 grams of the oxygen. That's pretty cool. Now, I guess I can group all these together. We're going to basically find the limiting reactant. Okay, so what I like to do is I just like to set this up into a chart. What I'm going to do is I'm just going to break this down the middle and call this as 2 things. So I'm going to say that the first top tier is what and maybe I'll do this in a different color to not clash with the black. So the first category is I have, right? I have 30 grams of the propane and I have 75 grams of the O2. The second thing that you have to find out is how much you need, or I need, right? Now, in order to figure out these, you're going to do stoichiometry. That's where this whole thing comes into play. Now, I don't care which one you start with. You want to start with the 30 grams of propane? That's fine. You want to start with 75 grams of oxygen? That's fine. But you're always going to solve for the other component. So if you start with 30 grams of propane, you're going to find out how much you need of the oxygen. And if you start off with 75 grams of the oxygen, you're going to find out how much you need of the propane. Since this one's on the left, let's start off with this one. And now I'm going to use this little stoichiometry little thing. We've seen this many, many, many times before, right? And we're just going to cater it to what we have. I'm going to start off with the 30.0 grams of not A anymore, but the propane, right? C3H8. And from there, I can find out how many moles of the propane I have, right? C3H8. And from there, I'm now going to find out the moles of the other reactant. So this is going to now be O2. And then from there, I'm going to find out how many grams of O2 I actually need. So this is our whole little schematic here. Beautiful. So now let's start doing the ratios. You have 30.0 grams of C3H8. We're going to use our ratios, right? Multiply by a ratio. We don't want grams anymore, so that goes on the bottom. We want the moles of C3H8 because that's where we're going. This is a gram to mole ratio of the same compound. That's using the periodic table. And if we use the periodic table, it's always 1 mole. So you put the number 1 next to where the mole is, and then you go on the periodic table and see, well, what is 3 carbons and 8 hydrogens? So let's just do that quickly. 12 times 3, roughly, and then plus, how many hydrogens? 8? Okay, so I get roughly 44, I did the exact numbers, 44.094. 44, maybe I'll make my 4s a little bit better. 44.094, you get the gist though, right? Grams cancel out with grams. We're left with the moles. We're moving on. So let's do my next ratio. I want to go to moles of O2. So mole of C3H8 is on the bottom. Mole of O2 on the top. And if you have a mole to mole ratio of different compounds, that's your balanced equation, BE. All you're going to do is you're going to find where these are on the periodic table and just say how many you have by the coefficients. So here was oxygen, right? So I have 5 O2s. And here was the propane. I have only 1 of these because I don't have a number. So I'm going to put the 5 next to the oxygen and 1 next to the propane. And that cancels out these. Now, let's just keep going. Times by the ratio. We put mole of oxygen on the bottom. Look over, right? I'm just getting the grams of the O2. This is now a gram to mole of the same compound. That's back to the periodic table. 1 mole, right? If we're using the periodic table, it's always 1 mole equals the mass on the periodic table. In this case, it would be 32 because you have 2 oxygens. And now, let's finally just calculate how many grams of oxygen I would need if I used 30 grams of the C3H8. So let's see. 30 times 5 times 32 divided by 44.094. Yeah. Okay. So I would need 108 we'll say 108.9 grams of O2. This is how much you would need. So I need this amount. And this goes where the I need is for the O2. So I need 108.9 grams of O2. Okay. Now, we just have to compare the two values. If you have 75 grams and you need way more than that, is there going to be any left over? No. The amount that you need is way more than what you have, and therefore, for this, you would have no O2 left. There is no excess, right? There would be excess if this number was less than 75. So let's just say for a minute that you only needed 50 grams of O2. Do you see how if you only need 50 and you have 75, you're going to have some left over? But in this case, you have no excess. That means that all of the O2 will be used up. And if all of the O2 is used up, so I'll just say all used up, that is the definition of a limiting reactant. The limiting reactant is the one in which there is no excess at all. So who is the limiting reactant? O2. Because that reactant, you will not have anything left over. If you did it the other way, in which you started with 75 and you worked to find out what this number, chances are this number is going to be less than 30. It probably would be something like anything less than 30, 15, 20, whatever, but it would be less. And you would see that you would have left over. And that's it, guys. So there's the answer. O2 is a limiting reactant. Thank you so much for viewing the video. I really hope this helped. Let me know in the comments, okay? Good luck on all your future tests and quizzes. And if you want to help us out, please press the subscribe button. Thank you so much. And I'll see you in later lessons. Bye for now. Bye-bye.